In the depths of space, far beyond anything the human eye can perceive, the James Webb Space Telescope has captured something that shouldn't exist. A galaxy so massive, so well-formed, and so early in cosmic history that scientists are now forced to rethink how the universe evolved. It was found just 280 million years after the Big Bang, a time when, according to our models, galaxies like this simply shouldn't have been there. This is the story of Webb's strangest and most exciting discovery yet, and why it could change everything we thought we knew about the early universe. The James Webb Space Telescope, launched on Christmas Day 2021, is humanity's most powerful window into the cosmos. Unlike the Hubble, which sees primarily invisible and ultraviolet light, Webb peers deep into the infrared spectrum. This allows it to look through cosmic dust, and more importantly, to see light stretched by billions of years of cosmic expansion. Positioned 1 million miles from Earth, at a gravitationally stable point called Lagrange Point 2, Webb operates in the cold darkness of space, shielded by a massive sunshield the size of a tennis court. Its mirror is made up of 18 gold-coated hexagonal segments, giving it unprecedented sensitivity to faint, distant light. In short, Webb isn't just a telescope. It's a time machine, looking back to the universe's earliest chapters. One of Webb's primary missions is to find the first galaxies that formed after the Big Bang. Astronomers expected to see small, faint, irregular objects, the first building blocks of galaxies. In theory, the earliest galaxies should have taken hundreds of millions of years to grow. They should have been sparse, dim, and primitive. But Webb had other plans. Not long after beginning its science operations, Webb pointed its golden mirror at a tiny patch of sky, and what it saw changed everything. While scanning a region known as CERS, the Cosmic Evolution Early Release Science Field, Webb detected a faint but unmistakable signal. It came from a galaxy so distant that its light had been traveling for more than 13.4 billion years. This placed it just 280 million years after the Big Bang, making it one of the earliest galaxies ever observed. But distance wasn't the only surprise. When scientists analyzed the data, they found something they couldn't explain. This galaxy was too massive, too bright, and too structured for its time. By current cosmological models, a galaxy like this shouldn't have been able to form so quickly. And yet, there it was. Webb's instruments, particularly NIRCam and NIRSpec, played a crucial role in this discovery. NIRCam captured the faint redshifted light from the galaxy, stretched by the expansion of the universe. NIRSpec then analyzed its spectrum, confirming its extreme distance and surprisingly mature properties. This wasn't a vague blob of light. The data revealed a well-developed stellar population, potentially containing billions of stars, less than 300 million years after the universe began. The discovery was verified through follow-up spectroscopy, eliminating the possibility of closer, misleading objects. This was real. And it was puzzling. To understand the shock, imagine the universe only 2% into its lifetime. Stars are just beginning to ignite. Galaxies are forming slowly from clouds of hydrogen gas. In this era, known as cosmic dawn, astronomers expected tiny protogalaxies, not fully fledged cosmic giants. Yet the galaxy Webb detected appeared to have already assembled a large mass, potentially equal to or greater than that of the Milky Way's early ancestors. This contradicts models of structure formation, which predict that galaxies build up gradually through mergers and accretion over billions of years. Either this galaxy formed much faster than we thought possible, or something fundamental about our understanding is missing. The astronomy community responded with a mix of astonishment and excitement. Some scientists described the discovery as a potential paradigm shift. Others cautiously suggested that perhaps our models need refining. Papers quickly flooded the astrophysics archive, proposing explanations. Maybe the early universe was more efficient at forming stars than we thought. Maybe dark matter halos collapsed faster than predicted. Or perhaps new physics is at play, altering how structure emerged in the first few 100 million years. Whatever the case, this galaxy forced theorists back to the drawing board. Several hypotheses emerged to explain this anomaly. One idea is that the initial mass function, the distribution of star sizes, was skewed in the early universe, favoring the rapid creation of massive, bright stars. Another suggests that cold dark matter behaved differently than expected, allowing structures to form faster. Some more radical theories propose that our understanding of cosmic expansion or gravity might be incomplete, hinting at new physics beyond the standard model. Of course, there's also the possibility that this galaxy represents an extreme but rare outlier, a cosmic early bloomer that formed under perfect conditions. The truth remains uncertain. But that's what makes this so fascinating. This is just the beginning. The James Webb Telescope is still in the early years of its mission. Future observations will search for more galaxies like this one, to determine whether it's a rare exception or part of a larger, hidden population. Deep field surveys, spectroscopic follow-ups, and new analysis techniques will shed light on whether our cosmic timeline needs rewriting. Meanwhile, upcoming telescopes like the Nancy Grace Roman Space Telescope will complement Webb's discoveries, painting an even clearer picture of the early universe. If more impossible galaxies are found, we may be on the brink of a scientific revolution. Every time we think we understand the cosmos, it throws us a curveball. This single, distant galaxy, shining from the edge of time, reminds us how much there is left to discover. The James Webb Space Telescope hasn't just given us sharper images. It's given us deeper questions. What else is waiting, hidden in the darkness of the early universe? As Webb continues to peer deeper, one thing is certain. The universe is far stranger and far more magnificent than we ever imagined.